Hey everyone, and welcome. Now, imagine for a second that you could build something, anything, not with bricks or wood, but with individual atoms. That's what we're talking about today. It's called atomic layer deposition, or ALD, and it's a technology that lets us construct materials with just mind-blowing precision, one single atomic layer at a time. And trust me, it has the power to change just about everything, from the clothes on your back to the medical implants inside our bodies.
Okay, so here's our game plan. We're going to start with what ALD actually is. Then we'll get into the nitty-gritty of how it works its magic. After that, we'll see why it's in a class of its own compared to older methods, check out some incredible real-world uses, and then peek into the future to see where this is all headed.
All right, first things first. What in the world is this revolutionary technique? Let's break down the basic idea. At its core, atomic layer deposition is basically the ultimate form of precision building. You know, if you think of regular manufacturing methods as being like spray painting a wall, it's fast, sure, but it can be a little messy, a little uneven. Well, ALD is like placing individual Lego bricks one by one to build a completely flawless structure. It's all about total control, but on a scale that's almost impossible to imagine. So how do we get that control? It comes down to a few key principles. First, it's a process that uses vapor. But the real secret sauce is that the chemical reactions are self-limiting. Think of it like a puzzle piece that only fits in one empty spot. Once you put it there, the spot is filled. No other piece can go on top of it. That's exactly what self-limiting means. Each step in the process goes until every available spot is filled, and then it just stops. It physically cannot add more than one single layer at a time. And that is what guarantees perfection, even on the craziest, most complex 3D surfaces you can think of.
That sounds pretty wild, right? Almost like science fiction. So how does ALD actually pull off this perfect, self-stopping layer? Let's walk through the really clever step-by-step process.
It all boils down to this really elegant four-step dance. It's kind of like a recipe with two main ingredients. First, you puffed in ingredient A. It spreads out and latches onto the surface, covering every single open spot. Then, step 2. You purge the chamber with a gas to clear out any extra A that's just floating around. Next, you puff in ingredient B. Now B is designed to only react with a layer of A you just put down. It won't stick to itself or anything else. And finally, step 4, you purge again to clear out the extra B. And just like that, boom, you've created one perfect, complete atomic layer. You just repeat that cycle over and over, and you can build a film to the exact thickness you want, atom by atom. So, as you can probably guess, this super unique process gives ALD some major advantages over older, more conventional technologies. Let's really see how it stacks up.
Now, what I find really fascinating here is the trade-off it shows. I mean, look at the precision. We're talking atomic scale, and its ability to perfectly wrap around complex 3D shapes, what we call conformality, is just off the charts. Because you're building layer by layer, the films are super dense and totally free of tiny holes or defects. Now, is it slower than other methods? Yeah, for sure. But here's the thing. For mission-critical parts, like the billions of transistors on a single computer chip, that difference in quality is absolutely everything. You just can't have any defects.
Okay, so we know how it works and why it's so special. But where is this microscopic process making a huge real-world impact? You might actually be surprised to learn where ALD is already being used.
For starters, let's talk about the clothes we wear. ALD is literally turning everyday fabrics into high-tech, high-performance materials.
This is so cool. We can basically give our clothes superpowers. By laying down these ultra-thin coatings, we're talking materials like titanium dioxide or zinc oxide, we can make fabrics flame retardant or give them UV protection. We can make colors more vibrant and the fibers themselves way more durable. And the best part? The coating is so incredibly thin that the fabric stays totally flexible and breathable. You'd never, ever know it was there. Okay, next up is an application that has truly life-saving potential, making the medical devices that go inside our own bodies safer and way more effective. Now, the key word here is biocompatibility. An ALD coating can make something like a titanium hip implant way more resistant to corrosion inside the body. It can create surfaces that are naturally antibacterial, which helps prevent dangerous infections. It can even add special bioactive films that encourage our own cells to grow onto the implant, helping it heal and integrate so much better. It's literally making medicine safer, all at the atomic level. So the applications we have today are already incredible, but what's just over the horizon? Let's take a look at some of the challenges and the really exciting future ahead for ALD.
Now, of course, the technology isn't perfect. It's got some hurdles to clear. Like we mentioned, it's slower than other methods. The special equipment and the chemicals it uses can be pretty expensive, and some of the films it makes can be a little brittle. Right now, the biggest challenge is figuring out how to scale all of this up for massive industrial production. That's what engineers are really focused on.
But the road ahead is just, wow, it's so exciting. Scientists are working on what they call green ALD, which uses less toxic materials. They're pushing for more processes that work at lower temperatures so we can coat delicate things like plastics. And get this, imagine combining the atomic precision of ALD with the total design freedom of 3D printing. We're on the verge of creating completely new kinds of materials for things like next-generation optics and electronics.
And that brings us to one last really big thought. Atomic layer deposition gives us, as a species, the ability to design and build materials from the ground up, from the most fundamental level possible. It's the ultimate toolkit. So the real question isn't just about what ALD can do for us today. It's about what massive problems we'll be able to solve tomorrow, when we can build absolutely anything perfectly.